Hello everyone, I'll be presenting my FYP topic which compares 4 different variations of an exercise called bend over row on an equipment called Flywheel. So what led me to create this topic? I'll begin by explaining what is the Flywheel equipment. Flywheel is a sports equipment that offers unrestrained resistance using concentric muscle actions to maximize eccentric muscle actions known as eccentric overload. It is on par with traditional resistance training such as free weights, being able to increase strength and muscle activation in different populations. There are many researches that uses Flywheel to measure its physiological effects, but it is mainly towards the lower limb and isolated upper limb. Currently, there are no literatures measuring the EMG responses of Flywheel towards compound upper limb exercises. Bend over row is one such example that could be used for Flywheel because it's a compound exercise focusing on the back and shoulder musculature. Strengthening the back helps to prevent back disorders, and strengthening the shoulders help to reduce shoulder injuries. There are no literatures yet that measures EMG responses of this exercise in the Flywheel equipment. Because of the limited research, this led to this research question with 4 different variations performed. Here are how the exercise looked like during my investigative study. The purpose of the study was to investigate muscle activation and eccentric demand of the shoulder and back musculature. In my hypothesis, I believe that there will be lower eccentric muscle activation of the back musculature performed in a seated variation, while similar or greater eccentric muscle activation for shoulder positions. Because of the research gap to fill, this study could contribute to better understanding Flywheel eccentric bend over row for training. It could be used for training considerations regarding shoulder positions and whether to challenge the back musculature or to avoid high back loading. A quantitative repeated measure study design was used to assess the EMG responses of the muscles as shown. All participants were also required to perform the following procedures at THEi Chaiwon campus. Healthy SRM male students were the investigated subjects for the study. Students were required to sign a PAR-Q and informed consent form in order to be transparent of the investigative study. Exclusion criteria included those with injuries and surgeries which could affect eccentric maximal performance. Subjects with more than 20% body fat were also excluded due to EMG signal dependence of the muscles examined in this study. To ensure reliable EMG data analysis and collection, they were instructed to avoid caffeine and avoid exercise 2 to 3 days before the sessions. They participated for 2 sessions total, one for familiarization and another for experimental session. Subjects were required to do a familiarization session to ensure proper strategy to perform the Flywheel and many more. During the session, they were also required to do MVIC test, which is used to normalize EMG readings with the raw EMG data gathered from the exercises. Here is how the process of MVIC test looked like. They had to maximally contract the intended muscles as hard as they can. Few days later, they would finally do the experimental session to extract the raw EMG data. After extracting the MVIC and raw exercise EMG data of every subject, they were all presented neatly in this table format as mean and standard deviation. To analyze the data gathered, fragment test was used, and when there was statistical differences among the 4 variations, post hoc test was performed as shown here at the top. Wilcoxon test was also used to independently compare muscle activity of 2 different variations. As you can see here, I visualized the EMG activity of both contractions with the concentric highlighted in gray for comparison, which was based on the table shown previously, using the mean to create the graph. Here, the pure colored bars represent standing variations, and the striped bars represent bench variations. From the results between the post hoc and the Wilcoxon, the shoulder musculature has mixed findings between shoulder positions in both standing and bench, starting from the upper trapezius to the latissimus dorsi. For the erector spinae, both results have statistical differences between standing and bench variations in the same shoulder positions. Mixed differences of the shoulders could be because there was not enough statistical power to draw out accurate and similar conclusions. Because of this mixed results, previous literatures were used to determine which one of the results are more supported. When it comes to the back musculature, results showed lower activations in bench variations. Because the chest is supported by the bench, this allows less involvement of the erector spinae with the already stabilized spine and proper hip angle, resulting in lower loads towards low back, aligning with other studies having less EMG activity in bench than standing. As for the shoulder muscle activity, limited studies were able to show different control strategies, similar muscle engagement with reduced EMG activity during eccentric contractions. So why the similar muscle engagement? This was able to align with a theory explaining that because fewer motor units are activated, With the increased tension of the muscles, this results in similar muscle engagement of the shoulders because eccentric tasks are more difficult to control. For the latissimus dorsi, abducted position demonstrated higher muscle activity. This is in agreement with a study that also showed similar muscle activation performing with a dumbbell bend over row. Although the research only analyzed concentric contractions, the results in this study adheres to the biomechanics of the latissimus dorsi. However, there are no studies yet to strongly support the results findings, especially with a limited sample size. When it comes to the isotonic contractions, the reduced muscle activity of the eccentric contractions could be because of the neural response, the activation of the Golgi tendon organ to protect against excessive loading to the body. Because of this, slight but not full contractions could only occur, resulting in reduced EMG activity during the eccentric phase. To measure whether subjects performed more eccentric demand is not possible in the study. In order to do so, force sensors or a device called a K-meter could have been used to measure eccentric overload and force output. If one wants to focus on the shoulder and back, it is recommended to perform standing regardless of shoulder positions. If you want to activate the latissimus dorsi more in a standing or bench position, you can perform it in maximum shoulder adduction. To avoid high back loading, it is recommended to use a bench, regardless of shoulder positions. Future investigations could measure eccentric overload and force output to better understand and manage exercise prescriptions and monitor measurable eccentric overload for the upper limb. This is the end of my presentation. Thank you.